Welcome. My name is Gurvin. I'm project manager at Norwegian Cognitive Center. And the reason why we're here today is that we have to prepare the organizations and every kind of organization for the change that is coming. If we see one technology shift that is coming, that is AI. And AI is the most important technology that will increase value creation in a large number of industry in the next year to come. And that's why we have established Norwegian Cognitive Center. And Norway is falling behind. Innovation Norway has done a survey among our different neighbor countries, and we see that companies that is thinking about starting using AI and company that actually use AI is very significant different from our neighbor countries and to Norway. So we have to do now something. And Norwegian Cognitive Center is here to help you, SMB market, to enable your competitive advantage. And we have a solution for you that you can use free of charge that we have called AI Industry Sandbox, where you can come with your own data and you can put on other kinds of data. You will have your own environment to work in where you can build and you can test different kinds of AI or cognitive technologies. And you have 387 different cognitive software solutions where you can build and test your data. Whatever you come, wherever you have your data or wherever you want to export your data further on. And we also provide you with free help trying to identify your use cases, or you need a data scientist or data engineer to help you. We will also provide you with some hours free of charge so you can use this. We have different kinds of activities. The next activity will be in March, where we have a more tech program where people, where presenters from Grieg Seafood will present. We have Storm Geo will present, and Sparebanken Vest will present their projects, and this is a more tech approach on it. We also will, due to this spring and autumn, have 5 ABC AI courses together with Digital Norway. And we start the 21st of April with the GC Ocean cluster, and we'll follow up on PropTech, seafood, finance, and media. Welcome to this event. The first presenter is Dag from Sharecat. He is also one of those who took the initiative to this event because they are working with different cognitive technologies and they want to network together with other companies from different kinds of sectors that are working with the same kind of problem. So Dag, welcome.
Thank you all. So, thank you very much, and thank you all for joining the session today. And as Odd said, this was an idea that came up in a session we were presenting on last fall. So thank you also to NCC for arranging this. The thinking behind it from our end is basically that obviously there are specific challenges to be resolved in different industries, but there are also probably some generic things that need to be resolved or can be resolved in a collaborative manner. So that was kind of the background for bringing this idea to Odd. What I'm going to do today is talk to you a little bit about our journey in AI and machine learning in particular. I'm CEO of Sharecat Solutions, and what I plan to do is give you a little bit of background on the company, so you understand when I move in, talk a little bit more about AI and machine learning, you have the context of what we are trying to resolve here. And today I'm also so lucky that if any of you guys come up with some complicated questions, I have the local expert from Sharecat sitting in the room, so I'll take the easy questions and Natalie will take the more complicated questions that might arise from my presentation. So anyway, so Sharecat Solutions is a probably not very known to many of you. What we do is we deal with, and when I'm going to talk about data, data in our context is equipment data. It's actually all the components that make up production assets. So for example, an oil and gas platform offshore, production platform would typically consist of 200, 250,000 different items all pulled together as a operating unit. So every time I refer to data and information, it's related to those kind of data. So again, I'm just setting the context. The other thing is also, I'm not here to brag about how clever we are. I'm here actually to tell a story about where we are. And I think what we've learned over the last months when we've been engaging this is that right now, I would say we have more questions than answers. But I think that's a good thing because we're digging into it. As you see from the slide here, I refer to what we do as practical application of data science for asset-intensive industries. And again, oil and gas is one, chemical industry, nuclear, offshore wind farms, hydropower, all kind of complex production assets is basically what we've been working on. And the wheel here, I'm not going to go into detail on that, but basically when we saw that as a kind of a representation or description of a data science process with hang on, this is what we've been doing for 25 years without actually knowing that we were doing data science. But this is basically what we have been doing. Our company is based in Bergen, built in Bergen, and operated from Bergen. Unfortunately, this morning we had a little hectic morning because of the situation in Ukraine, because we have an offshore development team sitting in Kiev. So I guess you can imagine what my morning has been filled with. But anyway, we're working our way around that, and I think the most important thing there is to make sure that the people are safe. We'll always work out the operational things. We've been around for quite a few years, and as you see here, we were born in the oil and gas industry. Oil and gas is still our major client base, but we are moving now towards other industry verticals. So we just recently won a global bid with one of the world's largest chemical corporations. I can't mention the name yet, but we'll come back to that. So we are really at the edge of having the need to scale dramatically, but also then we can't scale with people, we need to scale with using technology. But as you see here, some of the world's largest corporations is our customers, but we also have small ones, like you see Aragon, a small engineering company in Bergen, 50 people. You have BP, ExxonMobil in the other end of scale. So we are basically working with these guys in their context. So we deal with multi-billion-dollar projects and activities down to smaller few million type of activities. So what do we do? Sharecat, it's a cloud platform that we have developed. We've been developing this for more than 20 years. And the general idea about Sharecat is basically having a tool. It's almost like a front-end system to all the engineering systems, ERP systems, document management systems to deal with data. We're collecting data, we are defining requirements, we are collecting data, we are validating, structuring, standardizing data, and making it available for operations, for building, for maintenance, modifications, and so forth. And as you can see on the diagram here, on the left-hand side, you have all these multiple sources where the information comes from. e.g. in building a production platform offshore, for example, you're looking at 5 to 7 million data attributes. And again, equipment only. I'm not talking about process, I'm not talking about downhole geological data. This is the asset data only. So for one single plant, this is the volume of data we're talking about. And you would have several thousand companies involved in that process, in building, in providing components and the associated data and documentation that's needed for the building process, for the operations and maintenance process. So it's a major task that we are embarking on. What we're also trying to do here is basically say we're not SAP, we're not going to be an ERP system, we're not going to be an engineering system, we're not going to be a document management system. We're here to actually make these systems work. Because the complex supply chain I just described actually results in fairly poor data. Our business started actually in doing data analysis and cleansing for a local, partly state-owned oil company. And the status of the data were not very good. But they were not alone. We've been now working with multiple of these big guys, and the quality of the data is poor. You don't find necessarily the exact data that you're looking for where you expect it to be. And it's not necessarily of the quality you need. And what do we mean by quality here? For example, I'll get back to it a little bit, but the quality of data is if you don't describe uniquely what an item is, then it appears as two different items. Again, on the Norwegian continental shelf, if you look at the oil and gas industry, we are talking about 3 to 5 billion Norwegian kroners of excess inventory. They bought a lot of parts for their inventories based on the information. And if the information is not exact, you can see you have what we call duplicates, and then you start buying way too much. So that's one of the kind of value props or use cases we're looking at. If you can uniquely identify, know exactly what this is, then you have the option actually to optimize that. And the same goes for the whole building process, operation process, and so forth. But as you can imagine, this is a huge task, and we're talking big volumes of data. So this is also why we now started embarking on, okay, how can we actually, as I said, utilize new modern technology, AI and other technologies to actually improve and automate and scale what we're doing in a much more efficient way than we do today. We have a cloud platform that's working quite well. It's deployed worldwide. We are in all continents of the world. Is actually using our platform today in big projects. One example I can mention is in Iraq. So the system is being used in Iraq, the world's 4th largest oil field. Very harsh environment in many aspects. But the data on the system is safe because it's operated from Sognefjorden. So they're all okay in that respect. So they're utilizing our platform, and all their suppliers worldwide is actually accessing and using the system. Data science, as I said, is basically what we're trying to illustrate here is basically what we do today. And we're doing it with bits and pieces of conventional technology. But we've started to look at machine learning and artificial intelligence and the capabilities of that. How can we make use of that kind of technology to deal with these big volumes of data, but also being able to scale without having to add more and more people. So, hopefully this is readable. One of the things we are doing then is obviously we got kick-started on our journey here together with Odd and IBM and looked at what are the potential for us to do something with the data. And obviously this is an area where I'm not the expert. Obviously this is where Natalie becomes the expert. We have different types of technologies. Where we have what we call named entity recognition. You have what we call record linkage, you have image, and you have text classification. And what we're doing here is looking at these different types of techniques or technologies. How can they apply to what we're doing? On the named entity recognition, what it is very often is about is to extract information and take it from any data source and put it into a structured data set. Is that a feasible technology for us to use for that particular purpose? pulling out information from millions and millions and millions of equipment data? Question mark. We're looking into it. We are exploring different technologies, talking to external companies who have some experience in this area, looking at that. When it comes to the record linkage, it's about describing, how do you describe an item? You can describe the same item in many different ways. I use what's an acronym here, everybody loves that. RDL, Reference Data Library. It's basically a classification scheme. What do you call a thing? What is this? Is it a glass bottle, or is it a soda water bottle, or what is it? So what we're doing here with the RDLs is basically saying that from these different oil companies, engineering contractors, suppliers, etc., they call the same thing different things. But how can you get it about actually standardizing that, taking it from then different languages, if you like, and pull it into a common structure? And how do you know what is what? And how do you compare these things? Because what we're seeing in the industry that there's no global naming convention available. And I don't think that's going to happen in our lifetime. So again, we need to deal with different ways of doing this. So we're looking at then utilizing this kind of technology to map and then represent one thing from one language to another language by utilizing this type of technology. The other thing is also looking at images. Can we, via an image, actually identify what type of equipment this is? And here we refer to class and model. And class and model tells you if it's a given class, then you know what are the data you need associated with that. How do you describe this? What are the data elements that describes this bottle, as an example? So that's the type of technology we're looking at there. The other thing is also about document classification on the right-hand side here. It's about when you have a given component, and let's say it's in a dangerous zone, explosives, fire, high risk for fire, then you need specific certificates. You need to certify that that component's actually made for that particular purpose. Okay, can we then use this type of technology to identify when you need these type of documents? Can we then pull that out, classify it as an ATEX certificate or whatever it is? So, so these are different ways we now are embarking on, and Natalie, our lead data scientist, is literally working on this and see how can we actually utilize many, or all of these technologies actually to get where we want to get to. But what we have, which I would almost say decided, is that AI and machine learning is not the answer to everything. It's good for its purpose, but it's not necessarily the answer to everything. So what we're looking at is basically how do you combine, I would say, conventional software and software development with AI. So we see our platform actually now and in the future actually consisting of machine learning elements, components, but also conventional software, if you like. Because we don't think one is going to replace the other. It's about finding what type of technology is fit for purpose. Right. Am I good in time? Perfect.
Thank you very much, Dag.
Do you want to have questions or comments now?
Yeah.
Okay. Yeah.
If there are any questions for Dag, we take them now. You get a microphone over there.
Yeah. So I'm wondering, what were the main challenges with implementing machine learning or like a machine learning pipeline in Sharecat?
Well, I guess so I guess what is obviously Natalie can help here, but I think the main challenges is basically the shift from actually having people conventional technology and then actually transferring that to having technology take over the work. Obviously, we have had to work with our people, the team. So obviously there is some resistance there, but we are, when I say the program, it's basically also about making sure that we have these training programs. We actually educate the employees to do this. Obviously, the other thing is data and data availability and the structure of that. We have a large database with a lot of data ourselves, but there are also data sitting in multiple formats and shapes. So it's actually also assessing the situation there. And again, getting back to these different technologies, what do we apply where? So I think it's about actually finding the right technique, if you like, for the right purpose, but also then make sure that obviously if you're going to use machine learning, you need data. So data is kind of a key element here. How do you actually get the whole data? But also, I think we're on a good route in terms of the employees. They're all kind of starting to understand that this is not going to kind of take their job away. It's going to change their job, but it's not going to take the job away. So we'll have a lot of emphasis on that because there's so much knowledge in the people. And as you saw in one of the last diagrams there, to do this, to train and get, you also need people. So you need these experts actually in the loop to make sure that when you predict, is it right, is it not right? So again, you learn and learn and learn. So that's why I think it's really important to get our subject matter experts along with this, have them motivated and work with us. So I would say get the people on board, data.
Great, thanks.
I have a question.
Yeah.
Budgeting this process.
Yeah.
How do you do that?
Smart. Now, what we're trying to do is we have so the technology that the Sharecat platform is like 20 plus years old, so we're actually embarking on a huge investment today. And I've got the kind of the board and owners' approval to spend money. But what we've done is that we have obviously some conventional elements of the platform that's being developed using conventional technology. And then we have the AI machine learning element. So what we've done there is saying that that was a part of the investment is still defined more in an R&D context than the other part, which is more milestones, deliverables in the classic way. And we've been working with the board, and we have skilled people on our board who understand this and see the potential. And once they saw the potential, budget was not a problem, basically. Yeah.
When we first talked, you came to us with more or less, I think it was 21, 23 different kinds of use case.
28.
28, okay.
Approximately.
What we see as a challenge is to define those use cases. When we talk to a lot of different companies, they're interested and curious, but when we just then start to talk to them with regards to use cases, they are not very sure how to attack this. How did you and your team develop those different use cases?
I guess we did a complete assessment of the whole value chain. So again, it's like Sharecat platform is our product. That's what we do for a living. So it's not like a support system. This is our product. So this is kind of the core of the business. It's our factory in principle that produces value. So one of the things we did, we looked at the whole value chain and looked at where do we see the biggest benefits? What are the benefits? What are the savings in terms of own effort, but also what are the value for the different stakeholders? And then we started to prioritize that and said that, okay, we identified areas where we saw big value, savings or business potentials, and grouped it like that. So it's like the value, but there's also in some areas, some instances, there's a logical sequence. Because if you want to do this, you need to do something first. So it's like you can do a automated process here, generate some data, then you can have manual intervention, and then you can move the data to the next phase. So it's also looking at kind of a logical approach to this. But then we've kind of started to select then some areas. And in this scalability, where I mentioned this global rollout that we're looking at, there's going to be thousands of suppliers engaged in this. So obviously what we call the supplier interface, OEM, the guys to provide the original information that sits in these production assets is the source. So we're going to draw attention towards that kind of use case. We don't necessarily know, and what we're doing there is together with Natalie and the team looking at, so what shapes and forms does this come in? So one of the challenges we have right now is actually that this, again, the client I'm referring to, we're talking about a giga project in China. Obviously, there are a couple of other challenges related to that, but it's literally thousands of suppliers, and we need to then investigate together with the client what type of shapes and form is this data in. And then we'll look at these different technologies and apply it accordingly.
Thank you very much. Other questions? Then we say thank you to Dag.
I guess just as a final comment, as I said initially, we're open to collaboration, so feel free, anyone, during the breaks, or you saw my contact information. We're more than happy to talk to people to see if there are areas where we can gain some synergies. So we're really open-minded and looking forward to potential collaborations.
Thank you.
Thank you.
The next speaker is Karl Ove Aarbu from Tryg. He is also a lecturer with the Norwegian School of Economics, and he is also a part of Norwegian Cognitive Center's advisory board, trying to help us to do the right stuff for the organization out there. Welcome, Karl Ove.
Thank you. So, thank you for the invitation, and thank you for listening. Hopefully, and you presented me, so I will not do much about that, but I can start basically. You know, Odd, you gave me a very long title. So it was so long that I struggled to understand how I could fill that title. But in the end, I just translated the title to a shorter one, which is in red there, using AI to get the upper hand somehow. But I think during my lecture, or it's not a lecture, or my small speech, that you see that also the original title, how we can actually use AI for innovation, will also be hopefully answered during my speech today. So let's see if the technique works. So my disposition for this speech today is I will first talk about Tryg just briefly, and then I will start to try to describe where we are, you know, in order to get value out of AI and data science, machine learning. You need to take a position, you need to understand where we are, basically. You need to understand the as-is situation for your company. And after I've done that, I will basically also walk into, I think, 3 fundamental things you need to have in place in order to make AI a success in your company. So that is kind of disposition of my speech. So what is Tryg? Actually, this year, Tryg is taking the first position in the Nordics because last year Tryg bought Tryg Hansa, or all the Royal Sun Alliance operations in Scandinavia, except for Codan in Denmark. So today, Tryg is present in all Scandinavian countries. We are number 1 in Denmark. We are number 3 in Sweden, where we have 2 companies that are merging together now, Moderna and Tryg Hansa, and Tryg and Codan in Norway also merging together during this year, and number 3 also in Norway. So we are kind of quite large company now, and our AI and data science, it's a Nordic. We have a Nordic view on that, and I'm being occupied the last 3 or 4 years actually building up data science as a discipline both in Denmark and Norway. Okay, and feel free to ask. Maybe we can now take questions afterwards, but feel free to interrupt me during my speech. That's nice. Okay. So there is one hand and the other hand, you know, always. When we started thinking about, you know, using AI, take advantage of the capabilities data and machine learning and AI in general can give us, we have to understand that we are really an old company. So Tryg is like here in Norway, you know, Vesta was the first company. It was established in 1880. The Tryg company, which is from Denmark, it was established almost 250 years ago. Really old, really old. So, and it's not a digital company, you know. And in the start, everything is analog, basically. And all the processes inside the company, all the decision authorities and everything, is kind of built in, it's ingrained in the walls, you know. So when you start putting AI and all these new things into such an organization, you need to understand where you are. So that's a challenge. It's a cultural challenge. It's a competence challenge, and it's a walk. It's not a walk in the park, as I say. If it's a walk in the park, it's a really long walk in the park. Really long. On the other hand, insurance, you know, it's based on data. So, you know, insurance price, or what we call the risk premium, is basically you pay me for, and I take over your risk. So in that respect, we need to have statistics and, you know, all kind of algorithms that actually can, you know, calculate the expected loss from you, and so on. And the insurance premium you pay is basically your expected loss if that event happens. So, those insurance companies not managing, you know, to calculate the expected loss and use statistics, they are not here anymore. That, you know, that's a fact. So we have used data since the first insurance. I think it was 1,000 years ago, maybe even more, where you have to have some information about the probability for an event, and if that event happens to you, then of course what's the expected loss for that event. So then take the probability times the amount we expect, then you get the insurance premium. So that's also a crash course in insurance. And so we have an abundance of data. We need to use the data, but of course today, compared to say 10, 20 years ago, we have now suddenly real-time data. We have what they call exponentially increasing process power, and of course more and more skilled workforce. Even though data scientists are very hard to get, and it's a big competition. So this is important, you know, an important background for when you start to think about AI. So what should you do, and what should you think about when you're trying to establish, you know, data science? We can call it as a discipline in your company. Well, I think the first and the most fundamental thing is that you really need to have control over data pipelines. In a company, you know, you Sharecat, you actually collect data from companies, but in most of these companies, they have like tons of systems. So in our company, I think it's like 50 or 60, 70, 80 different data systems. You have a policy system, you have a sales system, you have a customer, customer care system. You have all kinds of other IT systems, like and when you're trying to follow a customer, you will find that the customer, when you follow that customer journey, and you want to understand, for example, customer behavior, it turns out that this customer has footprints in, say, 10 or 20 different systems. So if you really want to map that customer journey, understand the customer journeys, and maybe if you can collect data from all those systems, stitch them together, and do that for all your customers, suddenly you can see patterns, for example, from that customer journey. That means that, well, this and this pattern means that the customer will leave us, say in 30 days, most likely. With that kind of pattern, another pattern, this customer is most likely wanting to buy something, and so on and so on. But having just, a partial, it's like a puzzle, You have 60 puzzle pieces in your final puzzle, and if you just have data from one of these pieces, you are having some information, but not enough information to understand what's going on. So this is, I think, the first vital thing you need to think about. Tear down, or what do we call it? Tear down the silos, or connect the silos, so that you actually can understand what's going on. And also, there is some small points there. It's also important to understand the production data, not just a replica or some parts of the production data, because a customer moves. When you encounter a customer, you are encountering the production systems. So anything, so as close as possible to the production system, you should always try to be there. And it's also really important, so say you're putting some AI into that customer journey. So say that, for example, you have stitched your data together, you have built a predictive model somehow, for example, predicting more sale, predicting churn, whatever, then don't forget to keep your data, keep your predictions, and put it back to your data repository or your databases. Because you really want to retrain your models, and you really want to validate your predictions over again and in a continuous manner. So actually building feedback loops, I call them feedback loops, from your models back to the production system, compare your predictions and your actions with what actually happened. Well, that's really important, because the model, the AI model, must learn in the same manner as human intelligence must learn. So when we do something stupid, we have collected that memory, we have a feedback loop back in the brain, and we usually don't do that stupid thing again and again and again. So that feedback loop is really important. So, and the other point I want to, stress a little bit is understand your context and use, the right algorithm for the specific use case. And one thing I really think it's very important to think about strategically is, should your AI, should your machine learning model, whatever you want to build, should that be an assistant for humans, or should it replace human decisions? So that's because if it's like a decision support, for example, in the insurance, it can be in claim handling. Some of the more advanced claims, typically you get a ton of paper or PDFs. You have to read, lawyers sitting, reading, have this event actually occurred, and understand, is this covered? It's a lot of, advanced things there to understand. And we could, for example, build a text algorithm that actually, extracts the important things from all the PDFs into one pager. So when you do that, you're making this AI for a decision support, which, for example, Swiss Re told me that they have built something there. They have reduced the average time of actually handling a claim for maybe 8 or 9 hours, which is very, very valuable to do that. Sometimes you can make your AI as a decision maker, but making an AI as a decision maker replace the humans with an AI, well, then you really need to understand that, I think the quality of that AI must be, you have some higher thresholds for actually thinking when you want to implement it as a decision maker. So that's one really important thing. And of course, you have to understand, I think, the data generating process, and also understanding the benchmark. What are you competing against? Because if you are replacing humans, you should, of course, test whether your AI decision maker is better than the humans. And it can be, sometimes if the AI is more efficient, you can have a lower quality of that AI decision, but it cannot be too low, because then it's better to keep the human intelligence in place instead of replacing that human with AI. And it's also important for the cultural understanding in the organization that you need to be very transparent, and if you can make your AI implementation explainable, it's sometimes very difficult, but the more explainable you can do it, the better, and the more easier the adoption in the company will be. And start crawl before running, That's some standard thing. So, and the third thing I think is it's what we call data democracy, that you should also, in order to be successful, you cannot just have a small elite group of AI soldiers just working in the corner. You have to ingrain the culture of using AI and to expand it, so you have a sufficient teams or sufficient number of people actually, understanding AI, starting to use it, and basically because you have to reach that, the critical level of competence in the organization in order to get the ball rolling. So build and nurture a data-driven culture and share and knowledge, in a secure way, which is also in the GDPR world, it can be difficult. So so maybe we can illustrate with a ladder, and in the lowest part of the ladder is like starting to provide insights for all the business units in the company. It's really important, because then you learn to look at the data and then take decisions. And when you've done that in a good way, and that enough people are, doing this, then you can maybe build simple AI models for decision support. You can then learn where you can do it more easily. And maybe the third level could be building AI models for taking decisions. And if you're really advanced, of course, you can do things like Google do, and the most advanced companies in the world. They actually, have a continuous reinforcement learning AI models, based on which is updated and learned, and actually in what we call reinforcement learning. These robot vacuumer are based on reinforcement learning, for example. They learn when to vacuum, or when they feel that the battery is too low, then they have to recharge and so on. And so this is, I think, data democratization is a really important step here in order to be successful. So, and looking at use cases from an insurance company's view, so if we, in this slide here, I'm trying to illustrate the customer journey, in the blue line, at the lower end of the slide there. What's happening in the customer journey? Well, the insurance company, for example, select, type of risks we want to achieve. So then, for example, we can think of models for picking the right leads. When we have onboarded the customer, then, of course, or the customer is interested, we have all these models for calculating the right price, and also different models for, making the customer journey into Tryg or whatever the insurance company as smooth as possible. And when the person is, onboarded, or the customer is onboarded, then and a claim comes ahead, for example, we can build AI models for actually figuring out whether a claim should be accepted immediately or should be sent to a manual claim handler. And for those models, we have some of these models, you try to maximize savings, maximum savings in those models. And when it comes to, in our company and most non-life companies, typical you enter a renewal process where you have contracts for 1 year, and when the year passes on, at the end of the year you have to renew your policy. And then we are interested in to keep the customers that are valuable for us. So we are really interested in to understand which customers can leave us, and if we see that there is a high probability, well, could we do some actions to actually prevent them leaving? So in our company and all insurance company, banks and everything, where you write contracts like that, you should think of the customer journey, and you have to think of critical points in that customer journey, and start to understand where can I use data and information to build the right models. And in the future, we have sensors. You mentioned sensors on platforms and everything. We have also big markets for telematics, where those sensors can provide actually a lot of opportunities. Can potentially revolutionize insurance, because you could, for example, think of an insurance that could be cool, but it's quite very advanced. So when you park a car, you can automatically, you just have the insurance covers that actually happens when you are not driving, you know. When you start your car, you can extend your coverage because then you are exposed for new risks and so on. And when you park a car again, you can, you know, these coverages can dynamically be adjusted based on your behavior. So, you know, internet, so you can potentially pay your insurance as you live, as you drive, as you travel, as you behave. And it's not there here yet, but, you know, that could be a potential way. And, you know, the red line, the green curve there is actually, you know, from when you are very young, you typically have very few covers, like you have a personal insurance, you have a travel insurance, you have a content insurance. And along the way, when you know, starting having family, children, and everything, you see that your insurance portfolio grows and grows. And then you get old again, your insurance portfolio falls because your needs for insurance are less. So this green line is actually the life cycle of insurance covers, and it's a real, it's the real shape of the. I've just not put the numbers on the axis there. Okay, so my concluding remarks. I hope I kept the time. So remember, that's an old saying. I think the market is just your servant, but AI is basically your servant, not your master. You are the master, so you have to figure out where to actually put AI and how to actually, you know, do it the right way. And before you're thinking of the most advanced models, fix your data, tear down the data silos, and quality of data is, you know, can you actually connect them together? Understand your business and the data generating process. And then if you do that, you have to do it, keep the, you know, to build and nurture your organization so that you actually create that data-driven culture through the democratization and AI. And, you know, you can never stop. It's a journey that never stops, but you have to start it. That's for sure. So thank you. That was my.
Thank you, Karl Ove. Questions from the audience before I start?
You mentioned the trust among the employees, and you also mentioned that earlier, that it's important. But since you're a business to consumer, do you also feel that there is a need to build trust towards the customers on using these, both to collect data, of course, but to use it in practical manner?
Yeah, if you mean, you know, of course, it's if you think about a situation where it's really spooky, if you are on the internet and click on something and I call you just 2 seconds after, that's maybe not building trust. Is that what you're thinking about, for example?
Yeah, I have one example actually, where quite recently, where you are agreeing to fill in data about what the damage that's happened and that kind of thing, but your selection, what you really want to select is not there. It's other. And at the same time, it's like we do this automatically. So you put in the alternative other, and then they say we will take care of your case automatically. It's a little bit. Then you put in a very limited data or a very broad range of data. Then you sit as a customer, perhaps that you don't. I don't want a machine to decide on, because then it's just rolling the dice. Yeah.
It is. It's of course, trust is. I think it's really important to, you know, that the customers are informed, and the process you have is as much as possible transparent. But I think in a case where if you have very little information, we send that to an AI algorithm. Typically, it will, even though it's tested by a machine, most often, I guess, it will be actually sent to a claims handler. So, but of course, as a customer, you cannot see that.
Exactly.
Yeah. So, trust trust from customers is of course is really important. Huh? And if you and therefore we and all other companies are, we are asking people whether they want a machine, or that we actually can be asked for your consent to process this automatically. Even though we give you consent, we are not necessarily do it actually. But for a lot of cases, ticking off the consent there for the box means that in some cases you are actually paid out seconds after, sometimes. If it's a really small claim and everything seems good, then and that's the good side of it, getting the money very easy. And but of course, it's a balance. It's a good question. Thank you.
Other questions? Tryg.
Thank you. I guess it's more a kind of a comment along the lines you're referring to myself. And one of the things we're looking at, similar to you, it's like we don't have consumers, but we are business to business. And the OEMs, or the original manufacturers, are really important in this. So the way we decided to go about to create trust is say we don't just expose a piece of technology. We actually engage, particularly now in the beginning. We literally engage with people, and we then use technology a little bit behind the scenes to demystify it. And then we also are trying to be transparent. This was the source data, and this is kind of how it looks. So again, as you say, building trust. So it's really, I guess my comment is a really important point, actually, not only internally, but also externally, from the users and consumers of the data.
I can just also mention the new regulations, GDPR, are making very high hurdles to actually, so we cannot use, so we are very restricted now to actually use everything, It's not an anarchy as it was 3 or 4 years ago. The Facebook scandal and everything, what happened there. Yeah, no.
Tryg is a very, very big organization. Lots of departments, HR, sales, claims, etc. How do you prioritize what kind of use case we should start building AI solutions for? Is it the different department coming and the business developers there coming saying we want this, or how do you use? How do you build your use case, and how do you prioritize it?
Yeah, so most often we have business units coming to us. And we are starting, the journey is typically starting with a workshop with the different business units. And we have some hypotheses about what kinds of things we can automate or make more intelligent. And then based on those hypotheses, we are making a list, basically. And then we have to try, and then we have to validate whether this is possible or impossible to do. Because it turns out that often on the top of the list there is, for example, it could be, for example, automatic intelligent processing of building claims or other personal claims, whatever. It turns out the data is not available, or the data is sometimes at vendors and sometimes inside our house. And it turns out that there is a huge investment cost, for example, getting all the data you need. And then validate this, maybe 3 or 4 months it takes to do that. And if the investment cost is too high, we have to move down to second. It turns out that that things are more complex often than we think.
Regarding complexity, is it like this that you are, okay, here is the use case, we think that there are third-party algorithms out there, and you use that, or you adjust the third-party algorithms, or do you build everything from scratch by yourself?
Yeah, I think for at least for us, I think it's a core competence to understand what you're actually doing. We do have third parties that create things for us, but for example, then we cannot, for example, validate their predictions or algorithms we use, because then you have to make a contract that you also have to have the feedback loop. You need the raw data. So I think that's building that in-house, that core competence is that's the gold you create, and you should not. That's at least my view. You should not basically give that gold to others.
Okay.
Yeah.
Thank you. Other questions? There was one.
So you mentioned recommender systems, and that's a class of algorithms that usually is thought of as only being applicable for the entertainment industry. So I was wondering, what's your use case for using recommender systems in Tryg? Yeah,
well, that's it's a good question, because I also can answer it, I think. For example, if a lot of insurances nowadays you buy online, and like buying a book, whatever. So if you're buying a travel insurance, and then on the online site you can have some widgets or pop-up boxes actually reminding you about have you thought about this and this and this, and maybe this is a better option for you than this. So this kind of recommenders you can actually build on the online journey. You can also make a recommender like an assistant for a case handler. So the case handler can talk to customer, and when you talk to the customer and you get all the customer information, it turns out that you misses A, B, and C, and then you can pop up for the case handler. Well, this guy, maybe you can remind this guy about A, B, and C, and maybe we can sell some more, for example. Yeah. So that's.
Thank you very much, Karl Ove. Yeah. Now we take 10 minutes break, and we will be back at 2:15. Thank you. Hope you all got a good cup of coffee and a little break. We are now back, and now we're going to listen in to Anders Våge Nilsen, who is going to present how the prop tech industry is going forward. Anders, welcome.
Thank you. Yes, I represent the prop tech innovation cluster. It's a big cluster organization based in Bergen, but it's got members all over Norway. I think past 90 members from all along the value chain. And we've been working for some time on how to digitize and to improve productivity in the building industry and real estate industry, as well as doing something really, really important to revolutionize basically the industry that is responsible for a high part of the CO2 emissions, both in building operations, but also in the building materials and the construction process. And this is a crucial challenge, and it's also addressed at the highest level, especially in the EU currently. But there is a big problem. It's that a lot of the built environment is already there. So many of these buildings, about 97% of the building stock in the EU, is not considered energy efficient, and 75 to 80% will still be around in 2050. So we need to do something, and it's really urgent. So we need to work with the built environment that is already there and improve it. And how do we improve it? We have a set of conventional techniques to improve buildings energy-wise. But what we've explored in the project is how this toolbox is expanding. We have more technology available, and both technology, but also service innovation and new ways of utilizing the built environment. And also the whole urban systems are changing, in both related to mobility, but also how buildings interact. When using data in this challenge, we see three challenges. One is the fragmented data infrastructure. It's the data about buildings is really siloed across different systems and sources, and it's generated along a very long timeline. So when the building was constructed and all the sort of modernization projects along the way, all these data are fragmented and only partly available in a machine-readable format. The data quality is also low, so it's stored in unstructured documents. It's a lot of ambiguity. It's not easy to use, and we lack the contextual understanding. We can say a lot about the building and the geometrical features and the basics about the stuff that's constructed, but we cannot say something about how the building is used and why the climate context, what the local climate is like, is it urban or rural context, and how this building could be developed. So what we've seen is that we move a step further from one step further from the sort of traditional insulate the exterior wall strategy, and we see what other strategies could be applied. And we see that there is a big portfolio of strategies. One is smart optimization, where we can use sensors and control systems and switches, actuators to sort of adapt the building to the actual usage of building. So it's the smart building strategy. We could also see that the building is especially from now on in the coming years, will be a part of a smart grid. So it will respond to signals from the grid and to optimize the energy usage across buildings in bigger urban ecosystems. And this is a new thing where the building is not, it's like an island, but it's responding to its environments. And this is also could have substantial effects on energy usage on a city level, for instance. We also see that much of the footprint that is embodied in the buildings could be offloaded into new buildings if we manage to build a recycling industry and we manage to use more of the materials in new buildings or for new purposes, so that it's not like a end-of-life deposit. We don't deposit the concrete and the steel and stuff. We reuse it for new purposes. That would substantially decrease the embodied footprint of any building. We also see that we can produce energy with especially solar energy, there is a huge potential to produce and also store energy, both in electrical form and in thermic form within buildings. We also see that the people inside the buildings also represent a strategy. We could change behavior and incentivize behavior, for instance, related to waste handling in buildings, and also mobility to and between job and building and home, and we could play along with the users of the buildings in new ways and incentivize this using data. And we could also actually increase the usage of buildings. There are many buildings that are empty, a huge part of the day or at night, and so within a urban, if you have accounting on an urban level, you could increase the rate of usage in a number of buildings, and you could eliminate the need to build a new house or a new building. So we see all this as sort of the extended toolbox for green transformation projects in existing buildings. And we created a project called it Property Improvement System, where we aim to become a framework for data collection and analytics that will recommend strategies to specific properties. And this framework, we see it will serve both as like a logbook, a documentation system. It could serve as a scoring, benchmarking framework, recommendation engine, and also a sharing platform where these data can be available for third-party systems. We've seen sort of gone through the different sources of data, and what we see is we have some basic data that's not available at all. We need to talk to the property managers to actually submit the data into a database. It's like the baseline. So we want to create a self-registry where any property manager could sort of start a journey. Then we see there is a lot of public data, especially the cadastre, the matrikkelen on Norwegian, that's like the public registry of buildings, and also the new measurement systems for electricity. That is also a public API that's possible to tap into. We see that there is a lot of software around, and also a lot of files that contain data in a machine-readable format that we could use to sort of increase the understanding of the building. And we see also that user surveys, we could also use the actual daily users of a building. It serves as a data source if we manage somehow to collect that data in a structured form. And we also see that any building lives in a context. So there is a lot of surrounding data, both geospatial data around like where is this located on the map, what is the density of other buildings, what are the infrastructure conditions, what are the regulatory conditions around the building that is affecting and constraining and creating opportunities for transformation of an individual property. So what we want to do is to move away from the generic advisory system and make a more the building-specific system that could transform the building the cost-efficient and also climate-efficient way. One key element here is end of life. What is the rest life of this building? When will it be demolished or deconstructed? An average office building in Norway has a lifespan of 58 years. So if it's only 18 years left, then you probably should choose another strategy than if you have the full life length ahead of you. What we want to do is to create a logbook where we sort of gather this data on a high level. We don't want it to be a real-time database. But we want it to be a logbook where we can actually see the timeline of the building and see what happened to this building over time. And we want to create a scoring platform and also a recommendation engine that could be used for green transformations of individual buildings. So this is the ambition for the project. What we started doing now is that we created in collaboration with Norse, the researcher there. In a publicly funded project, we created an onboarding system where you could register buildings, and we get sort of the baseline data. Also get some data points that gives access to new data sources. For instance, we could, from this form, tap into the public cadastre database, and we could also apply to get the access to the actual energy usage in the building. This is a sort of a starting point to start exploring how this data could be turned into good recommendations. And we are working with pilot buildings right now in the beginning to make a generic model where we will open up for a bigger portfolio of buildings. And what we also did was we have been talking to a lot of the industry players to make like a registry of measures or tools to different things you can do with a building, basically, and to see what kind of buildings is this. Should this be applied in? What are the conditions that should be present for this to work, and also what possible effects could it have? And then we see both on sensory capacity, smart energy control, documentation, how well is this building documented? Because that's the deficit of documentation is a big problem in existing buildings. We did, the reason we call it property improvement system is it's also the pi, like the P, it's referencing to a circle. We created a system that's based on 6 times 6, like 6 dimensions and 6 indicators for each dimension. It's a very visual and very easy to understand system that is sort of the core in the more like human-facing interface that we will develop. So you could actually see how much, where you are compared to the best practice within this specific indicator. So you could gain theoretically 360 points within the system. This is like a gamification kind of interface. But we tested this and it works really well. It's really like an easy way to understand and to also visualize the improvement in different areas. So what we want to do, and we also see that when we're discussing with the researchers, that we could get a lot, like a very standardized data sets for a huge range of buildings, and we could implement things in the building and see how this affects the performance of the building in different dimensions. And this would be a big data set that would measure real world effects of different interventions. Also reflecting the contextual data. So I find this a really, really interesting use case for AI and also machine learning. But we're really early in the process. So we are really open for any collaborations. And also we need, of course, a lot of competence and experience from other sectors into the projects for this to happen. But I think it could have a huge impact if we actually manage. So we're really, really happy to discuss this project with the people that have been through this journey before. And right now we're working with the pipeline problem and also just to get sort of the data right and also just creating really simple algorithms. But I'm sure this project has a huge potential. So thank you.
Thank you, Anders. Questions from the audience? No, I have. This is a very traditional industry. How has this project been taken? How has the vendors?
responded to
the project.
No, it's we've got a lot of interest actually, especially from real estate managers, because they wanted a tool where they could see how they could improve, and also they feel sometimes that the advice that they get today is really traditional, and all these new this new, like, should you replace the whole envelope of a building, really expensive, or should you make some smart moves, some sensors to sort of just adapt the energy usage to the actual behavior in the building? We don't actually know the difference in related to a footprint. We haven't calculated that, so we know too little about the new ways of green transformation of buildings, and probably you should do often a combination. But and also we see that there is a huge interest in a lot of the third-party vendors that want to build new services on top of building, because they meet the exact same problems. They need to integrate with a lot of sources to get just a basic understanding of this building and the context. Also, the advisory consultancy companies are really happy if they could have one API and collect the necessary data. So that would sort of speed up because a lot of the work today is basically data finding. So we have got a lot of, but of course there is a lot of positioning in this. We try to make this a very collaborative, broad ecosystem, and we don't want to tread on anyone's toes. So that's a challenge, because we want it. Basically, what we want to do is make a business model that works in a way that over time would generate a really interesting big data set that could be used for research, because we need that research. We need actual real-world data to make good decisions. And this is partly about business, but for my part, it's mainly about good decision-making in a climate and environmental perspective. We need to we cannot just simulate or estimate, because these estimations are really not adapted to, like, you have the same advice for a house in Bergen and for a house in Finnmark, way up in the Arctic. And we live in two different climate contexts, so that's kind of interesting.
But you say one thing, that start small, just small sensor, and start beginning collecting data. And there is a lot of different startups in this environment, and there is a problem there fetching data, because there is a lot of data within Bergen Kommune example. But to fetch them, we meet the GDPR demands, and a lot of different startups are struggling to get data. Either to build solutions within. They have AI solutions, but they miss data. How should they approach the Entra and the owners of the buildings?
It's a tough question, but I think there's actually a problem. I could address that, because some of the, like now, it's really positioning, and people very often it's like you have one sensor, you build one software interface, and you build from that, and you consider the data like a proprietary the gold in your model, but what you need as a real estate manager is, and also a lot of the third-party services need a broad array of data. So you need data from a lot of different systems. So I think generally think we should have more and more openness. And also, we should relate to the standards that are actually in place, and also agree on how to, like the BIM model. There is a lot of variants along, so you should agree on a minimum quality level of data. So I think that you should lift this onto an industry level and discuss how can we actually make available the data that is actually there. This is partly due to data quality, but it's also partly due to business strategy, because there is a lot of proprietary mindsets around.
So what you're saying, that Entra should share the data they have on this building and let others use it?
It should be a procurement requirement from Entra that they get the data and they have the freedom to actually share it with other systems, so that the building owner actually has available the data on the performance of their own building. Yeah.
What's your biggest challenge going forward now with this project?
Right now we are kind of in the prototyping kind of stage. We are putting in the first properties in the system, and there is a lot of learning going on, and we have a very good relation with the team at Norse. So it's I think well, there was a lot of brain work and also interesting findings probably, but we have a broad scope. That's probably, so we need to focus on like narrow it down to specific questions. So that's probably where we are right now. Or we need to sort of just we need to remember why we are doing it, that this is actually a holistic model, but to get to the holistic model we need clarity on specific questions. So we are but it's right now is getting in the data and also probably to integrate the system with some of the APIs that are not that good always.
Thank you very much. Thank you for on that. The next presenter is a company where AI is in the core of the services. This is a fairly new startup, and Miguel Silva, the CEO at Visualist. Welcome.
Thanks, Odd. So yeah, I'm the founder of a company called Visualist. We are a company that's also part of NCE Media. We're quite often here in Bergen, in Media City Bergen. Our background is from companies that are quite central to Media City Bergen as well. And one of the things we decided to do was to take a look at how AI can actually help a very, very traditional workflow, which is the workflows that exist today in the TV and film industry. If we're talking about that prop tech is actually very, very conservative, well, it's even, I would say that other industries are also even more conservative, like certainly the case for broadcasting. Or let me put it this way: distribution of film and TV has actually accelerated and been quite innovative over the past 20, 30, 40, 50 years. We went from broadcast television over the air to cable distribution to streaming distribution, and then even technology companies like Facebook and TikTok and Google started coming into the producing content as well, or making content available, and that accelerated the growth. But the way you produce traditionally scripted content has pretty much remained the same over the same time period. And so we're looking at ways of how can AI actually take this very traditionally manual, heavy workflows in the production stage, and actually help you then, or in the distribution stage as well, and actually then help you to produce more content faster and better content than we have today. And so one of the things that we're looking at is the compliance review process, and very kind of like roughly stated what the compliance reviews are in this industry. It's a little bit like this. Number one, the world's appetite for content consumption is only growing. This is actually a real figure that I Googled not that long ago, and there appears to be, like the figures appear to support that now for every single human or every single adult in the planet, we consume about 6.5 hours of video per day. That goes across all television, all streaming, all the social media, video consumption, et cetera, but on average we consume about 6.5 hours per video per person. And also some other estimates that surprised me is that maybe about 80% of the world's internet traffic is actually video. So that just shows you a little bit the explosion that has happened in terms of streaming television, in terms of social media consumption for video, et cetera, et cetera. At the same time, we are living in, or TV and film are actually industries that are really quite regulated, that are heavily regulated. Every single country in the world has a regulator that has come out with regulations for what is okay and not okay to display on video. Some of that regulation is pretty old. Some of that regulation is new. Some of that regulation is changing, keeping up to the times. But basically, everybody has rules. And then if you have a country which stands for a disproportionate amount of video production, which is the United States today, probably about 50% of the world's content, professionally produced content, comes from the United States, about another 30% from China, about another 20% from India, and then the rest for the rest of the world. These are just like figures that exist out if you Google them. But whenever you have that environment, that means that there is content that is made once, sometimes for one given market in place, but it gets distributed in a lot of different markets. And it gets distributed, there's even now hyper distribution when you look at these type of numbers. Things very, very quickly make it out into other markets, or they should make it out very quickly onto other markets. But they don't today. Why? Because it takes approximately 2 to 5 hours of review time for every single hour of video that gets produced. It needs to be reviewed for every market in which it's going to be distributed. That is the compliance review process, basically. You have a group of people that are sitting, different teams that are sitting in broadcasters or in different, sometimes it's outsourced to different companies. And they're sitting, they take in all the video that is going to come out on television. They review it, basically the traditional moderation, if you will, role. They review it, so they have their checklist, they have their policy documents, they have their regulations. Sometimes they escalate it on to legal departments. Sometimes it goes on to a management to make a decision whether this is okay, not okay, et cetera, et cetera. Then it comes back to editorial, then they maybe have to make some changes, and then it goes out to being published. And that process takes a very, very long time. Sometimes it can take weeks or months before a single episode of a given series can be actually cleared for distribution in a given market. And it varies, like the type of work that you do actually varies a lot. You know, there's legal, broadly speaking, there's 3 areas of compliance. There's legal compliance reviews, technical compliance reviews, and editorial compliance reviews. Legal compliance reviews are things, you look at things like, for example, the music rights. If you have a movie with a very known soundtrack, it's not at all a given that you actually have the rights for reproducing that soundtrack to your audience in your market. You need to check who actually owns these rights, and then you need to clear those rights. And it can get very, very complex very quickly. Same thing can be for like brand rights. When I was speaking to a team in Sony Pictures, and they gave me a very good example. I talked to a compliance team that all they did was basically check whether any movie that was made by Sony Pictures that was actually going to be shown in Sony Entertainment Television, to check whether the shorts for those movies were compliant. And what they explained that some of the work that they do is like, if you have a movie for, let's say, a James Bond movie, and in that James Bond movie, like they're running around Las Vegas and they're shooting each other and stuff, it can be that you actually have the shooting rights. Well, you actually have like the production rights, if you will, to show the brand of that casino for the movie, but you don't actually have the specific set of rights, like the reproduction rights, if you will, for the name of that casino in the shorts. So you need to check these things, and then if you don't have the rights, then you need to remove that any scene where it's visible, the name of the casino, et cetera, et cetera. So it can be quite complex. And then one of the things that we're looking at, that we started looking at basically with our product, is the editorial compliance reviews. And those are things like there's different levels of nudity and violence, there are different tolerance levels for nudity and violence around the world. Also, there's a lot of different rules about content that is made for children cannot contain consumption of alcohol, consumption of cigarettes. There's a lot of age classifications that you need to add to different content pieces before they can be shown. In some markets, you're okay to show some of these things, but you just need to warn the viewer that there's going to be smoking, et cetera, et cetera. So it can be very complex in many different markets. And so you can imagine that again, this takes a very long time, and so and the stakes are actually really quite high as well. These are only some examples of some of the fines that have been. Just by Googling quickly, you find that actually the industry spends a lot of money correcting some of the mistakes, basically, that happened during distribution or during production. They spent a lot of money paying to the regulators by way of fines that are issued for things that could have easily been caught. If they had been caught before, that fine could have easily been avoided. And so what we do basically is we try to simplify all of that with AI. We came up with a product that is built in the cloud that allows then an editorial team to take in the content, that uses AI to crawl it and automatically come up with scenes or different frames or different segments that may be problematic based on a given policy that you've told it. If you're telling them, I want to scrutinize this for children content, so please look for any instances of nudity, violence, et cetera, then we kind of like highlight that for you, and then we have a human moderation as part of the picture, so then somebody can click on this is okay, this is not okay, and then you have collaboration in it as well, so that then if you do need to bring it onto a legal team or decision for another team to make, you can just tag them, you can make you can collaborate the same way as you can with a Google Doc. You can make your notes, you can tag people, you can assign tasks onto others, et cetera, et cetera. And so by bringing these two together, by bringing AI for the discovery and bringing cloud collaboration for the actual approval process, we're hoping to save a lot of time. And we do have actually some figures, some benchmarks that we've done as to how much time we actually do save. But giving you a very, very practical example of some of the things that we're working on. This is actually an AI model that we developed for PBS America. It was financed by Stadium. That's why I put up the logo. And by the way, if you don't know about Stadium, please look them up because they're a very, very good program. They're a very good accelerator plus grant program for media tech companies like us that are looking at bringing levels of innovation with AI or otherwise onto the media industry. So they gave us money. They gave us grant money for us to develop this algorithm for a specific customer. And the problem that PBS was having is they say, when you're doing compliance work, right now the way it's done, it's manual. You look at the video from beginning to end and you make your notes, and it's very easy for the human eye to miss something that is maybe in the background, that is maybe on graffiti, a bad word that's on graffiti, some hate speech that may be on graffiti, or that may be on the text that's maybe a little bit out of the way. Anything that's background information, that's not in the forefront, if you will, it's very easy to miss it. But AI is more consistent that way. We can actually look for text within video. We can find out whether that text is hate speech. We can find out whether that text is profanity. Whether there is any, if you're specifically thinking about GDPR and how it affects this industry, we can find out if you've unknowingly published somebody's email address or somebody's phone number or somebody's address on a piece of paper. And there have been cases. I do have examples of that going forward. But so then that was our challenge. And what we did is we grabbed the model and we trained it to be able to look for bad language, hate speech, personal information in the background and in text on video. And we trained that model, and that model is, here's a little video that shows you with the binding boxes how it works. This is actually an actual town that is in Austria. I don't know how you spell it correctly, or I'm sorry, how you pronounce it correctly, probably Fucking. But this is like a typical example, something that is that's in the background, or that it's like text that's on the video. And as you can see, some of this text is actually quite small. It's easy to miss. And so our AI does actually specifically look for this sort of thing and brings it out into the forefront, so that then a human can look at this and go, okay, no, but this is okay because it's in context. Or no, this is not okay. This we need to blur it out, or we need to do something before we can actually publish it out. And for people that think like, okay, but this is not really applicable for countries like Norway, well, I don't want to pick on TV2 because my background is from TV2, so I love them. But they did have a case, only last week, that maybe some of you are already read about in the news, where they had this program called SOFA. I don't watch the program myself, but maybe you guys know the concept, where you had this couple that was, I guess the show is you have people sitting and watching some sort of content piece and commenting on it. And so they had this couple that was doing that, and they had their dog, and the dog basically had in its collar, they had their phone numbers. And that actually got published. Here, of course, for this example, for the they blurred it out, but they didn't when it was on television. So a lot of people got hold of their phone numbers and started calling them. And of course, that in itself, technically, it's already a GDPR breach now. But no harm was done. Everything was taken in good humor. It was all just like an oops. But you can imagine that it can have a lot more serious consequences whenever you get hate speech involved, and people that that might not be as nice as the people that actually called them, et cetera, et cetera. It can come up, it can have real consequences, if you will. And so this is a case of where AI can actually help. AI can purposely be looking for phone numbers, emails, personal information that it's very easy for the naked eye of an editor to miss, and then show you that here you have an instance, and then you can decide what you want to do with it. So we've actually done some benchmarking with some of the customers that we have. We've trained some AIs for some of the media brands here in Europe. We have a few projects out in India. I mentioned also PBS America. And one of the things that we're seeing is like we're not purposely trying to reduce headcount, of course, but that is one of the consequences is that you don't need to have that big of a team. Think of it this way. If you're a rather large broadcaster, like let's say Discovery, and you have multiple countries, the traditional way of doing it is so you need to have a compliance team for every country. And then when you make a deal for a new country like, I don't know, Turkey, and then all of a sudden you need to deliver 10,000 hours of programming to that market, then you need to rush and like coordinate for reviewing all that content before you can send it off for that distribution deal. But if you start using AI and you like centralize things a little bit, you can have multiple policies, if you will, for all the world, and then you only need to run it once, and you get results for all these different markets. So unintentionally, then you are saving, you're saving time, you're saving labor costs, and time is the biggest thing that we're saving. And in our testing right now, that what we're seeing is that we can save about 67% of the time, and about 50% of the man hours that are normally used for compliance reviews, just by adopting modern technology, which is AI in the cloud. Essentially, that's what we do. If anybody wants to take a closer look at us and the tool, and I'm here. I'll be around, and this is my contact information. This is how you can get hold of me. And I hope that I stuck to the times. Odd, you let me know.
Thank you very much, Miguel. Do we have questions from the audience? No. You have done this for a couple of years now.
Yes.
How has the market received your company and your algorithm and concept?
Yeah, so number one, these past couple of years have been pandemic years, no? So it's been like many companies will tell you, this being a very traditional industry, it's always better to do business face to face. So it's been tough getting hold of people. It's tough to like get your message across. Also because people disappear or they get corona themselves and they're not in the picture, etc. So it's been very slow adoption. On top of that, when it comes to like the actual acceptance for AI, there is a little bit of a mistrust, like healthy mistrust of AI right now. Like one producer was telling me is like, I'm not really that concerned about false positives. I can delete flags all day long if you want to. But I'm very concerned about the false negatives, of course. I don't want to get fined $200,000 because we missed a nipple or something like that. No? So that's a healthy kind of like hesitation that there is to AI. With that said and done, there is a lot of interest because the industry is under a lot of pressure to become more efficient. As we've seen, the world appetite for video is only growing. A lot of the eyeballs are moving away from traditional media. There is, and also from like new entrants like Netflix, like HBO, like Disney, et cetera, et cetera. So a traditional broadcaster needs to find ways to do more with less. And this is certainly, this type of technology helps you with that.
This is much about business development also, because you had a prehistory before you come up with Visualist. Could you take a few words about that? When you research what you should do after your sabbatical year?
Yes. Well, so if you go back then to before that time, yes, I was working for a company that is a daughter company of TV2 called Vimon Media Solutions. I was the CCO, so I was heading a team of salespeople that went out and talked to many different broadcasters. What that company did and still does is took the development that was done for the OTT platform, the streaming television platform that was developed in-house by TV2, productified it and started selling it onto other broadcasters quite successfully. We did a lot of business out in the US, some business here in the Nordics, business out in Asia Pacific, and different select European markets. And one of the things that's when the idea started kind of like becoming when we started kind of like getting tipped that this is a problem, is because in a lot of these projects, the technology, the platform, the apps, everything that you need to launch a streaming service usually was in place a lot before the content was in place. And once you start digging into that, one of the reasons I found this because content needs to go through some sort of clearance process before it can actually be put into these streaming platforms. And just seeing some of the struggles that happen in those projects, then when I started discovering or stumbling into the world of compliance reviews. And yeah, there's many anecdotes of people.
Yeah, because you're touching on a couple of points there. One, you solve a problem. B, you have data. And that's what AI is all about. You have to have the problems. Without problems, you don't need AI. Correct. And you have the data. Correct. So this is a really good ending point for this session. Is there any questions to Miguel before we stop? No. Then I thank everybody for attending, and remember that 31st of March we have a similar session like this, but then on techniques, tools for data scientists, data engineers, and people who actually work with algorithms. Thank you very much. Next one.